Hello there, I'm Peter Nass from Kyndryl, and pleased you're joining us today for Series 2 of the Data Center Strikes Back, a deep dive podcast digging into data center networking for the enterprise. Last series, we focused on realities and relevancy of private data centers and covering key topics, including general data center growth, data center interconnect use cases, and the threat that quantum computing has on the security of the data center network. This time, our next 3 episodes will explore the major themes that are impacting data center network design and automation. And of course, I'll be joined by experts from Nokia and Kyndryl, 2 of today's global leaders in technology, innovation, and customer success, as they will share their insights, experience, and unique perspectives on the data center's strategic contribution and role as critical infrastructure. Let's start off strong. AI. It seems that every industry is buzzing about this swiftly evolving innovation, and the enterprise is certainly no different. They're avidly adopting AI left, right, and center, but how will data centers and network infrastructures need to adapt to support these future business applications? Joining me today are Clayton Wagar, Principal Consulting Engineer from Nokia, and James Knights, Principal Architect from Kyndryl Consult. It's great to have you both here today.
Thank you, Peter. Nice to meet you, Clayton.
Thank you.
Okay, the presence of AI in the marketplace is clearly upon us in a big way. And that has sparked, enterprise interest and adoption into, a bit of a feeding frenzy, you might say. We see these tech companies flourishing, be they hardware, software, or cloud. So if we consider AI from, the lens of infrastructure, meaningful for us, we think about often workloads and that supporting infrastructure. We hear about different workload types for AI model training, AI inference, things of that nature being used in the context of public cloud, private cloud, and edge. So Clayton, if I could start with you, if you could take a few minutes to perhaps, you know, demystify or characterize these workload types and generally how they might be relevant for the enterprise.
Absolutely, Peter. Thanks for having me on today. I appreciate it. So, in the news today, we hear a lot about AI, and a lot of that news is oriented around this new asset class, the GPU, right? We have companies that are worth more than they've ever been worth. NVIDIA, really refactoring themselves from being a gaming company to an AI company. A tremendous story of our time in technology. But when you drill into what it is that those GPUs are doing, it gets kind of interesting. So, your listeners who may have studied AI, been listening to news in the space, have certainly heard the terms training and inference, right? And these are really 2 of the modalities, 2 of the big types of workloads when we take these GPUs, these hundreds of thousands of GPUs, put them in the network. The type of traffic that they generate, the actual network traffic itself, it's very different between these 2 AI phases. Training, this is something that the largest labs are going to be doing. OpenAI, Meta, XAI, Anthropic, all these names that we hear. These folks are generating these massive foundational models, if you will. ChatGPT is the one that most people are familiar with. Google has Gemini. These type of models require a tremendous amount of horsepower compute, and they have tremendous network traffic patterns. They are very chatty. They're all talking at once. They're doing so, over thousands and thousands, tens of thousands of iterations. So when we put these in the network, we need to have a network fabric which is robust, provides extremely high bandwidth, very low latency. And these type of workloads are expensive to run. So we expect in the long term a lot of these to continue to run in the largest public clouds and in clouds that are designed for AI specifically. That's training. Once you have a model that's trained, an enterprise then would adopt a certain model. So Llama is very popular, a model named Llama from Meta. An enterprise would take this model and would further take their corporate data, their proprietary data, all the things that make them a business, and they would then take that model and train it with this additional context, this additional data. Think about all the Word documents, the PowerPoints, the emails, all of that critical business data. in order to make sense of it. That type of workload is something that we certainly expect to run on premises at an enterprise. And enterprises of all sizes will have their own GPU clusters that will further train on that data. And then when you run it, how people use the model, how do your corporate citizens use and interact with a model? That's inference, right? We are inferring things with the model. And those certainly will be a mixture of public and private workloads on-prem, in the public cloud, really depending a lot on the scale, the unit cost, the needs around data sovereignty and privacy, those sort of things. So different types of workloads running on this new asset, the GPU, and they could really be anywhere from on-premise through a massive public cloud.
Yeah, I think that frames it up really well. So, James, are you seeing some of the customer perspectives sort of show up in whether it be responding to RFPs or just initial stage conversations with clients? How are you kind of seeing that show up for you?
We're seeing significant requests from customers. Some actual projects, a lot of them are just engineering concepts at this point.
Hmm.
But they're coming from banks to manufacturers to engineering firms, and they're all looking for the same thing. They want to build a small but powerful environment where they can run their inference workloads.
So, do you see like customers at various phases of adoption, whether they're like a full blown project or these pilots? How would you kind of, from what you're seeing, characterize? Wouldn't say the adoption rate per se, but at least the level of interest from that kind of spectrum.
Yeah, so there is an extreme level of interest. I work with a bank in Brazil.
Right.
I work with the government in Japan, right? Kyndryl has set up our own pilot project in Japan. And the interest is coming across the globe, really.
Hmm.
And it goes from small environments. We're talking about just a few dozen servers with a very small fabric, to in Europe where we're talking about dozens of servers with a very large fabric to support.
And Clayton, when your engagement with clients, are you seeing, them getting into where they were perhaps just investigating it or researching it and then getting into full blown like operational? What are you seeing out there?
Yeah, so we at Nokia, we as a larger provider of network infrastructure to the marketplace, we interact with a number of different types of companies, and their journeys really reflect the maturity of the market in the particular space they're in. When you're looking at what we would call standard data center fabrics, those are not associated with some sort of AI application.
Hmm.
We have been working with hyperscalers and with cloud providers, enterprises for a number of years now, and are well versed in that market. The design patterns are pretty well known, how to scale up, pretty well understood. When it gets into AI applications, obviously the new kid on the block, but the ones that are growing and really adding a lot of dynamics to our industry. We're working with customers, down in the 256 GPU type size, and are engaged with customers that are doing hundreds of thousands of GPU applications. So the readiness for folks does go all the way from trying to understand how they might, is this a cost center? Is this a profit center? Just the economics of AI are somewhat opaque to most enterprises. So we have folks that are investigating that all the way through those that are training and running models and doing inference with models that they've trained. So it does again really reflect, I think, the business value that a particular application provides in the market right now.
The notion of kind of a shadow IT, is there any kind of element of that happening where some maybe lines of business are wanting to get ahead of this and rank and file IT is maybe a little behind, or am I kind of making that up?
No, no, you're not crazy. We have seen occasions when we deal with customers, right? It is the customer that brings us in and asks for our expertise in setting up an AI or a private cloud. And we don't always get the request from the engineering groups. We're seeing the financial centers. We're seeing the manufacturing centers coming and talking to us about setting up a fabric so they can have a private cloud environment where they can set up an AI farm. So it's interesting. And Clayton, you hit it on the nail because, I'm old enough to remember IT in the beginning where it was an overhead for everybody. right? And if you look at corporations, they were all interested in their manufacturing side. They were all interested in their billing. And they were not happy with IT because we were siphoning off funds that they wanted to do for something else. And now when you look at it, a corporation cannot run without IT. So I'm wondering if AI is sort of going to fall in the same bucket where it is an overhead for now, but it will reach a tipping point where they realize that, hey, we can't really do our business anymore if we don't have this.
Yeah, no question about shadow IT. I mean, look, GPUs are expensive things. So, getting started with AI especially is not trivial. But if we have folks within enterprises that are scratching around and think they understand what the value are, those are your innovators, those are your entrepreneurs. An enterprise should really be looking for those folks and how they might take what is clearly going to be a massively important technology for civilization going forwards. If you have some early adopters who can find a way to do that, then as a CIO, I would endorse that completely.
The people that I've talked to, they have a business that they need to perform, right? And they look at AI as, well, this is a tool that will help us get what we need to do better, faster, cheaper.
Mm-hmm.
And so they come talking to us at Kyndryl because we have a practice built around data and AI. We have a practice built around networking. So we understand the infrastructure and the guts that it takes to put this together. But it is so varied. It goes from understanding business transactions and mortgages and loans to manufacturing new chipsets, right? And as Clayton said, it is somebody within the organization that had a vision and said, hey, I think this AI technology is going to help me get my business done faster or better or cheaper. And they meet us at conventions. They meet us over the internet. We've had people respond to this podcast, so which we hope will happen.
Yay.
And, it is a very varied section, if you want, of the enterprise population.
But talking about, Clayton, you've characterized the workloads. You've given us some insight as to, the demands of the network. You talked about latency a little bit and things like that. But looking at that network fabric, what are some of the characteristics of that network that need to be there? And maybe how sort of Nokia has the equipment to do that?
Well, what's interesting about this, the market that we're in now, the data center market for networking, is that we have two lines of heritage, if you will, coming together. We have data center networking, which now is probably 2 decades old. You have the hyperscalers, which have built hundreds of thousands, millions of CPU servers that hold all of our email and banking transactions and who knows what else. And then you have this other smaller but really sort of mighty part of computing called high performance computing. And this was the domain of researchers, typically at universities and labs, type of computers that were doing nuclear modeling and weather modeling, this sort of thing, still do. Splitting the atom, taking the data that comes from a Large Hadron Collider, this sort of thing. And the requirements of that high performance computing environment were so specific and so demanding. And artificial intelligence has really dragged those requirements into modern data center networking, into the thesis that we use as network architects to build an environment. CPU-driven servers, what we're used to having, which can have a wide variety of workloads doing any number of things in any sort of place. GPUs do something very specific. They do a single thing. They do it really well at very high speeds. And so GPUs, we have to design the network in order to support them where they are. Modern designs now for the largest players are at 800 gigabits per second. So they're really the highest Ethernet that we could provide today. And, I'd say that's the other key thing. There's also a transition, a movement away from using some of the more proprietary technologies in high performance computing. One of those is called InfiniBand. It's a fabulous technology. It provides a great service at a premium price point, as you would expect from supercomputers. Mm-hmm. So how do we let the Ethernet ecosystem, which has been so successful over the last half century, how do we let that inflect and help drive the unit cost, the economics around AI, and provide, hopefully a benefit sooner than it otherwise would by cost optimizing these giant fabrics. So Ethernet is once again showing itself to be a key technology around the expansion of, the technology universe we live in, how we connect, how we talk, how we communicate with one another. So we take a lot of that existing understanding, we scale it up, and then we add the specifics of AI into that and the demands that it has. And that's why we find ourselves in this growth period.
I've seen the InfiniBand sort of value prop kind of be there, and it still has certain values, but and James, I know you have too, right? So you've had that experience with InfiniBand and Ethernet. Ethernet always seems to win, right? And there's a lot of good reasons for that.
Yeah. So as Clayton said, InfiniBand was the vehicle that was developed by NVIDIA. It has very low latency. But it is extremely expensive because it comes from NVIDIA, and it's the only provider. Ethernet always seems to win, right? Ethernet beat out Token Ring. Ethernet beat out 100 VG from HP many, many years ago. And the reason Ethernet wins is because it is a simple design. There is a maximum in networking. Perfection is not achieved when you've put everything you can into it. Perfection is achieved when you have nothing left that you can take away. And Ethernet is that. It is a simple, effective communications technology and methodology. With the Ultra Ethernet Consortium, of which Nokia is part of it, and with algorithms like RawKey, you can now do what InfiniBand does. You have almost, and I mean, we're talking about fractions of milliseconds latency difference between Ethernet and InfiniBand at a much, much lower cost. So think about this. When you have a PC at home, and if you have a kid or a grandchild who's a gamer, right, you'll have a good GPU in your home PC. You will notice that when they're playing a graphics-intensive game, it gets very hot. You will also notice that you may have a tendency for some of your circuit breakers to pop. And that's because these boxes are power-intensive. Now, your smallest AI farm has 16 of these in a very compact, tight environment. I would hope that your engineering team and your infrastructure team has thought about climate and HVAC, and they've thought about power, clean power from multiple sources.
Yeah, that sort of leads me to that, surrounding design and architecture. Like, okay, data centers. How do customers look at building a special part of their data center, like the watts per rack and the need to draw that heat away from this section? You can't just like generic server farm this. You probably have to look at a special spot within your data center to outfit it or equip it that way.
I've been around long enough to see us go from 5,000 watts a rack to 10,000. Now we're looking at about 40 to 50 provisioned in a modern data center. It would be the low end, which is really, we're getting to the limits of air cooling with racks right now. So in order to support some of these clusters, AI clusters that are in the news, we're having to go to cold plate technology, liquid technology, in some cases immersion technology. So, we are the story of data centers today with the rise of AI is not just one of computers, it's one of infrastructure. A lot of what we have done in this space, even though we're only 2-3 decades old, the modern data center industry, we're having to rethink of so much. And just to return quickly to Ultra Ethernet's part of that.
Yeah.
It's a first principles discussion. If we were to design it today, would we do it the same way? The answer was no. And so now we're trying with Ultra Ethernet to build upon the standards-based Ethernet that James is talking about, but to provide it with some modern capabilities, just like we are, again, in other domains like space, physical power, electricity, sustainability.
Yeah, and those are domains that we at Kyndryl have a fair bit of track record and history on. So, James, I guess when customers would look at setting up this different paradigm of like power and space and cooling and our experience with data centers over the years and our heritage as it was, I'm sure there's a lot of engagement and advice and services that we probably engage with our customers on for such things.
Oh, absolutely.
Yeah.
Absolutely. And we see it across the world, right? So we have dedicated teams And normally, I should say that our data center teams are dedicated to what we call delivery. So they're brought in once we have an engagement with a customer to actually build the data center for the customer or to actually build a new section of the data center for the customer. That's a more common occurrence. But we are now bringing in our data center experts a lot sooner because we really need the customer to understand the implications. We have to modernize power. We have to modernize HVAC. We have to make sure the cooling is applicable for the amount of heat and power that these new devices draw.
Mm-hmm.
And so we bring our experts in at the beginning, and we bring people like me to talk about the networking side of things. And we provide the customer with a high level design that they can then determine if it fits their business model.
No, that makes sense.
And most of the time it does.
I want to try to wrap a little bit more of a closing thoughts on like, where is this going, right? We've seen over the last couple of years where this is taking us. What might the future look like?
I think that we're looking at a point where the technologies become so ubiquitous. You're going to be at a point where you're going to have these workloads, whether AI or traditional workloads, occurring anywhere within the environment. We have processing power coming down significantly into what it requires to be effective. So in the future, your laptop may be your AI farm. We need to solve some physics issues like cooling, but I think this is where we're heading.
So I think if you look at what we've done with internet technologies over the course of the last 3 decades, we've spent all of our time connecting people together, right? Through wireless networks, broadband, corporate networks, residential. We are at the beginning of the era of building the machine network, right? These AI agents that will be communicating with each other on our behalf. They'll be booking our holiday travel and diagnosing our medical issues and recording our memories in the cloud for future generations. All of these things, as they talk to one another and operate on our behalf, we're building the machine network for them, right? And the networks we built to date will become the eyeball networks that reach humans, right? The responsibility of those networks will really be a priority on us consuming content, but that content and the communications between these agents, these AI agents, will be so ubiquitous. And so that's the great thing about being in the industry that we're in, is that we get to see these generations and growth of things that need to communicate. And it's a great part of being human to communicate. And so at Nokia, we're happy to make that better for everyone.
I love this topic. This is good stuff. That's really all the time that we have for today. And I really want to thank you, Clayton and James, for getting this series going off with a bang and sharing your insights. This is a truly fascinating topic. This broad AI adoption is really kind of rocketing this latest and greatest renaissance in the enterprise data center with extraordinary business benefits that are being realized across the board with this advanced technology. Hybrid cloud models are taking center stage in the optimization of the DC network. These solutions and these architectures that are key to delivering this enterprise success. What's your take on AI deployments for your data centers? Let us know using the hashtag #DataCenterStrikesBack on Nokia and Kyndryl's LinkedIn, YouTube, or X. And for more information about what we've discussed today, please visit our websites. Next time on The Data Center Strikes Back.
So the shift has created this need for highly reliable network connectivity to ensure you have that seamless communication and data transfers. And that's where the data center gateway comes in.
So, we increase our capabilities, we lower latency, we have better performance, and we decrease the likelihood of our data being intercepted.
Because the gateway, at the end of the day, it's a huge part in allowing for these universities, whatever it is, an enterprise, organizations, to really push those bounds of innovation.
Today's episode of The Data Center Strikes Back featured Clayton Wagar from Nokia, James Knights from Kyndryl Consult, and me, your host, Peter Nass from Kyndryl. The Data Center Strikes Back is a joint production of Nokia and Kyndryl.